All right, so I think our next speaker is Hasin, and she will be introducing her work on using ChatGPT for drug-drug interaction extraction. Are you ready?
Yes, I am. Can you see my screen?
Yep.
Okay, thanks. I'm sorry. Hi, this is Rehana. I am a PhD student at the University of North Dakota. Today I'm going to present our research entitled ChatGPT for Identifying Drug-Drug Interaction from Biomedical Text. Adverse drug reaction causes 0.3 million deaths every year in United States and Europe. The identification of drug-drug interaction is vital for ensuring the protection of public health. However, with the rapid growth of biomedical literature, automatic extraction of drug-drug interaction has become a very important research area. So our objective is to investigate the effectiveness of a large language model, generative pre-trained transformer, or we call it GPT, by OpenAI in predicting potential drug-drug interaction from biomedical text, and to compare the efficiency with the existing state-of-the-art deep learning models to figure out if GPT can be good enough to detect drug-drug interaction from given text. So drug-drug interaction is basically a change in the drug's effect on the body when the drug is taken together with a second or maybe third drug. And a drug-drug interaction can delay, decrease, or increase the absorption of either of the drugs and cause adverse effect. It may cause death. So it's very important. So this is the breakdown of our approach. We have did some data pre-processing. We have taken the data set from web, and then we have filtered the drug entity pairs that have the drug bank ID only. We did not consider the drug entities that doesn't have the drug bank ID. We mapped the drug entity pairs with starting and ending at the rate, and we also did another mapping that drug entity names with drug 1 and drug 2 in the sentence. As input, we considered macro level and micro level. For macro level, we provided the input at document level, and for micro level, we provided the input at sentence level. We have applied 3 different generative pre-trained transformer model versions, GPT-3, GPT-3.5, and GPT-4. For evaluation metric, we have considered precision, recall, and F1 score, as these are the most common for this sort of researches. So you may have heard the name of ChatGPT, or you may have also used ChatGPT. So GPT is basically the AI model behind ChatGPT. However, it can do a lot besides generating human-like text. It can do classification, it can do question answering. And so we decided to investigate if GPT models can do good for detecting drug-drug interaction if we give it the sentence and some instruction that how it can handle the drug-drug interaction from the sentence. So the models we have used are GPT-3, GPT-3.5, and GPT-4. So GPT models are mainly known for generating creative human-like text. So you may have a question like how this model specifically known for generating creative text can get useful information and very sensitive information from the text for drug-drug interaction. So here we have used these models through API, and when we call this model through API, we can tune its parameters. For example, there is a very vital parameter of GPT model, which is temperature. And if we reduce the temperature, it reduces the creativity level. So if the temperature is almost 0, it does not give very creative very creative outputs. It gives robust outputs from what we need. So that's why we have used a temperature of 0.1 for GPT-3, and for GPT-4 and GPT-3.5, we have used temperature 0.2 in the range of from 0 to 2. We have used DDI2013 dataset, which is a benchmark dataset for drug-drug interaction. It has 5,000 true drug interaction pairs, but for this research, for now, we have used a subset from this dataset. So this dataset has two subsets. One is drug bank and another one is Medline. So we have taken equal number of documents from both drug bank and Medline. We have taken 64 documents from drug bank and 64 documents from Medline. And then we have considered the drug entities that have the drug bank ID only. And we have considered a total of 316 true drug interaction pairs. For this research, for now, we did not consider any negative drug interaction pairs. And as I told that we have applied two different mapping at the data pre-processing step. So we have the sentences by two types. One is the drug entity names enclosed inside the @ and another one is replace the drug names with hypothetical drug 1 and drug 2. Prompt engineering or query structure is very important for having good results, having informative and usable results from GPT model. So we have used two different prompts, slightly different prompts for these two settings. For example, I'll talk about this first prompt where we said that analyze each sentence to determine if there is a drug-drug interaction between drug 1 and drug 2 marked inside @ That is, then we have given the sentence with this query. So we have explicitly told that the model has to consider the drug names only inside the @ It will not consider any other drug names present in the sentence. And to get the results at usable format, we also have to indicate which output format we need and which columns are needed for us. So in the query, I also explicitly said that the output format should be tab delimited TSV table. The output columns should be the sentence ID, drug 1, drug 2, drug prediction that will be true or false, and a brief explanation about why the model is saying that yes, there is a drug-drug interaction, or no, there is no drug-drug interaction, so that we can track that the model is not giving us random results. And we have also indicated how many tokens it can have as the output row for each row. So the prompt for settings 2 is almost same, just we made it clear that the drug 1 and drug 2 are hypothetical drugs, and it has to predict the drug-drug interaction between drug 1 and drug 2. So in the data pre-processing step, we say that we have some mapping. So here is an example. This is a sentence. Here there are some drug names. At a time, we are going to consider two drugs. So here, this yellow one is the drug 1 and the cyan is the drug 2. So we replace the drug names with drug bank ID first. So here is the replaced sentence. And then we have applied two mapping. This one is we have replaced the drug names with drug bank IDs with the drug names again, but enclosed within the @ And here we replaced the drug names with drug 1 and drug 2 to hypothetical words. So this is the result for the setting 1. Here you can see that the GPT model does not perform that well for both document level and sentence level. However, GPT 3.5 has very good result, and GPT-4 at sentence level, it gives us 302 true positives among 316, which is very high, and the precision is 98%, the recall is 96%, and the F1 score is 97%. We have applied each of the models 3 times, and we have taken the average so that the result is consistent. For settings 2, you can see that again GPT-3 model, which is the legacy model from GPT family, it does not work that well for drug-drug interaction identification for both document level and sentence level. However, GPT 3.5 and GPT-4 has pretty impressive result. GPT-4 gives us 100% precision, 97.88% recall, and 98.89% F1 score. We have compared our result with some state-of-the-art models which were also applied on the same data set, and we have found that GPT-4 with sentence level setting 2 outperforms all the existing state-of-the-art models. So now let's look into an example drug-drug interaction. Here in the table, you can see several drug interaction pairs, and there is a common drug among them. It is warfarin, and this warfarin interacts with 6 different drugs based on the dataset we have used. And so we decided to do some ontological analysis for these drugs. We mapped warfarin and its 6 interacting drugs to the CABI ontology. We used the tool OntoFox to extract those terms and their associated axioms. And we have found that warfarin, cyclosporin, and fluoxetine are resmates. And then we looked for the common roles among these interacting drugs, and we have found that some of them have antidepressant roles. And then we found that among 6 of these drugs, 4 of them has the role of antidepressant. So there is a significant pattern among these interacting drugs. So I'd like to conclude saying that GPT-4, the most recent ChatGPT model, achieved a remarkable overall accuracy of 97.88%, which surpasses the previous benchmarks. These results indicate that a promising outlook for utilizing large language models like GPT and some others existing in drug identification and other relevant tasks. And also, after mapping to the CABI ontology, we were able to better analyze the drug-drug interaction information. So our future direction is to apply ChatGPT models to the complete drug-drug interaction 2013 benchmark dataset. We also want to fine-tune the ChatGPT models for DDI identification tasks, because this model is not trained on drug-drug interaction task. This is not trained on that DDI 2013 dataset. This is just a pre-trained model. We used the model as it is. So we want to fine-tune these models for drug-drug identification task, and we want to see if there is an improvement after fine-tuning. And we want to incorporate the biomedical ontologies, for example, CABI or IONO, etc., with our task. So this study was supported by NIAID. So that's all from me. Thank you. If you have any question, please ask.
Thanks, Hasin. Any questions?
Hello, may I have a question?
Yeah, go ahead.
Hey, Dr. Rehana, thanks for your great presentation. Can you go back to your curious rosters? You showed the 2 curious settings, something like that.
This one?
Yeah.
Okay.
And I'm curious, so since in your prompt deconstruction, you mentioned that you try to replace the original drug name into drug 1 and drug 2, right? These 2 names are previously allocated or is extracted by ChatGPT. I mean,
this is annotated by us. This is not annotated by ChatGPT. We have provided the annotated sentences to ChatGPT. This is in the pre-processing step.
Okay, so you previously allocated the corpus to extract the drug names like drug 1, drug 2,
Yes.
and then the ChatGPT will do the classification whether these two drugs has the relation or not.
Yes.
Okay, got it. Yeah, since I found that your the results, the performance is very, very high. It's so promising. Yeah, very interesting.
Yeah, and we have found that when we do not provide the drug names, instead we replace them with hypothetical drugs, it may get the pattern even better, and the result is better for this drug 1, drug 2 mapping, because in that case there is no bias from its existing knowledge, maybe. Yeah.
Okay, so can you go back to the performance table?
Yeah, sure. This one is for setting 1,
for
and
the
this one is for setting 2.
Comparison with the baseline.
Yeah.
Here. And so since you see the ChatGPT achieved very much higher, improved significant improvements, 20%, that's a very great, improvements. So I'm just curious, in this baseline worker, like the EGFI, something like that, 2022 worker, did they do the end-to-end, or they just did the same as your worker, is just to classify previously?
So these models are deep learning model. Yeah, they have trained their model on the data set, and then they have applied the for the test data set. Yeah.
Okay, I'm just curious, since this improvement is so significant. So I mean, did this baseline or this previously published worker, they just do the same task as yours, like they classify whether these two drugs contain the relation or not, or they try to do the extraction like the NER, then the relation extraction. That is the end-to-end worker, or they just do the following relation classification.
Thank you very much for your question. Yes, these are also classification tasks. They also classified either there is an interaction or not. However, I'd like to tell you that I told you in my slide that I did not use the complete data set. I have used a subset of this data set. And also one difference is we have considered only the positive interactions. Like for our task, for now, we do not consider any negative instances. Yeah. So this is the major difference between their approach and our approach. Yeah. And
so,
in future, we are going to, yes.
Yeah, so you just cited their results based on their experiment, something like that, their data. Okay.
Yes, yes, they have used the same data set, but they have used the full data set, and we are at the very initial stage of our research, and we applied the model only on a subset of the data set.
Yeah, it's very interesting. Yeah. So it may be helpful if you can provide it, like just try to utilize the baseline models, like the EGFI, something like that, to replicate their results using your data, your same experimental parameter, something like that, then to compare with your ChatGPT. So I think maybe that may be very helpful to show the greatness of the powerful of the ChatGPT. Yeah.
Yes, thank you so much.
Okay, thank you. Yeah.
Thank you. Thank you so much.
Any additional questions? If not, let's thank our speakers again.